Be a polynomial with multiple variables. Complicated but lot many solutions. So today in this video we will learn about the zeros of the polynomials. This is exercise 2.2. The link for 2.1 and 2.3 is in the description box. And before we start, please hit the subscribe button and the bell icon. Moving on to the next concept, relationship between zeros and the coefficients of a polynomial. So if I take a general polynomial as ax square plus bx plus c, I am taking a quadratic polynomial because the highest power is 2 and the constant a, b, c are actually the coefficients here. Now that means there are two zeros. Since the degree is 2 there, that means there are two zeros and I am naming it alpha and beta. Generally, any question which is given to you, there must be two zeros. So we are naming them alpha and beta. Now, how are these related? How are the zeros related to the coefficients? So sum of the zeros, that is alpha plus beta, is equals to minus b by a, right? That is the minus the coefficient of x upon the coefficient of x squared, and product of zeros, that means alpha multiplied by beta, it will give you c by a, or c by a will give you the product of the zeros. C by a here means the constant term and the coefficient of x square. So sum of the zeros minus b by a and product of the zeros c by a. Very, very important. Let's do some questions based on this. So exercise 2.2 now. Find the zeros of the quadratic polynomials and verify the relationship that we have just learned. So here, first let's find the zeros. How do we do that? First let's name it. So I'm naming it as px is equals to x square minus 2x minus 8. So I've named the polynomial now. And now I will put the polynomial equal to 0 so that I get the zeros. So x square minus 2x minus 8 is equals to 0. Middle term splitting, I think 4 and 2 will work. It will be minus 4. Minus 4x plus 2x minus 8 equal to 0, and x common, x minus 4, 2 common, x minus 4 equal to 0, and x minus 4 common, x plus 2 equals to 0, and x comes out to be 4 and minus 2. So we have got the two zeros of the polynomial. Now first let's find the sum on our own, right? So what is the sum of these two zeros? 4 plus minus 2, that is equals to 2. And let's find the product also on our own, that is actually equals to 4 multiplied by minus 2, that's minus 8. So this is what we have found on our own. Now we will see that what comes with the coefficients by applying the formula that we've just learned. So sum is equals to minus b by a. Now what is ABC in the given expression? A is 1, B is minus 2 and C is minus 8. So if I write down minus b by a, it will be minus of minus 2 by 1. We have reached plus 2 and this is what we got by adding them already. Then what is the other relationship? Product is equals to c by a. Now what is c here? Minus 8. And what is a here? 1. So I get minus 8. So I can see when I actually added them up and actually multiplied them, I got 2, I got minus 8. And when I applied the relationship, again I got 2 and minus 8. So hence, verified. Right? Okay, so let's move on to the next part now. It is 4s square minus 4s plus 1. So we to find the 0, I will name it first ps, not x, because we have s as a variable given, and then we put ps equals to 0. So 4s square minus 4s plus 1 is put equal to 0, and if I middle term split, and this is like a perfect identity also, so it is 4s square minus 2s plus 1 equal to 0, 2s common, 2s minus 1, minus 1 common, 2s minus 1 equal to 0, and 2s minus 1, 2s minus 1 equal to 0. So we get s equals to 1 by 2 and s equals to 1 by 2. So now we will find the sum first on our own. So sum of the zeros is 1 by 2 plus 1 by 2, that is 1, and product 1 by 2 multiplied by 1 by 2, that is equals to 1 by 4. So this is what we have done on our own, but now we will find it while using the relationship. So we have sum is equals to minus b by a. Now what is ABC here? A is 4, B is minus 4, and C is 1. Right? I hope that's visible. A is 4, B is minus 4, and C is 1. So now let's continue. So I'll put value here, minus b, that is minus of minus 4 will be plus 4 upon a 4, which is 1, and we're getting the same thing here also. Then let's find the product. Product will be equals to c by a as per the relationship. What is c? 1. What is a? 4. This is also equal, hence verified. Right? Let's move on to the third part now. It is 6x square minus 3 minus 7x. First of all, they are tricking you here because it is not in the right order. It has to be 6x square minus 7x minus 3. So your A is 6, B is minus 7, and C is minus 3. Right? The C is always the constant term. It is not the last term. It is the constant term. Now let's solve. So we will name it as px is equals to 6x square minus 7x minus 3, and then I will put px equals to 0. So 6x square minus 7x minus 3 equal to 0. 6x square minus 9x plus 2x minus 3 equal to 0, because 6 3s was minus 18. So I split 18 as 9 2s and 7, 9 and 2. So I'll take 3x common here. I'll get 2x minus 3 plus 1 common, 2x minus 3 equal to 0. So 2x minus 3 common, I get 3x plus 1 equals to 0. So I've got the two zeros, one is 3 by 2 and the other is minus 1 by 3. So now first we will find the sum on our own. So if we find the sum on our own, sum will be equals to, start the same way, 3 by 2 plus minus 1 by 3. I'll have to take an LCM here. That will be 6, 9 minus 2, and I will get 7 by 6. Then I'll find the product. So the product of the two zeros will be 3 by 2 into minus 1 by 3. 3 and 3 got cancelled, minus 1 by 2. Now I will find the same things using the relationship. So sum is equals to minus b by a. So what is b here? Using this here, b is minus 7. So it is minus of minus 7 upon 6, which is equals to 7 by 6, which is, this is what we had found ourselves as well. So we are going the right way. Then product is equals to c by a. So what is c? Minus 3 by 6. And if I reduce it, I get minus 1 by 2, which I got here also. So hence, verified. Next part, fourth part. Now 4u square plus 8u. Now here be careful, A is 4, B is 8 and C is 0. There is not any constant term there. But how will we find it? I'll write P of u is equals to 4u square plus 8u, and then I'll put pu equal to 0. So 4u square plus 8u is 0. I can take 4u common. I get u plus 2 equal to 0. Now never send a variable term to the 0. That means 4u is 0 or u plus 2 is 0. So we got the 2 as it is when there is a square in the quadratic polynomial. It is a square. That means there are 2 zeros. So u is 0 or u is minus 2. So I've got the 2 zeros, 0 and minus 2. Now let's find the sum. So sum will be 0 plus minus 2, that is minus 2. Then let's find the product. So product will be 0 multiplied by minus 2, which is 0. Now we will verify it by the relationship we know. What is the relationship we know? Sum should be equals to minus b by a. So what was ABC here? This. B is 8. So it will be minus 8 upon a, which is 4, and you get minus 2. This is what you were getting here also. Then product. Product will be equals to c by a. What is c? 0 by 4. Again 0. So this is 0 and this is 0. Again, hence verified. Let's move on to the next one. So t square minus 15. Now we'll have to deal some roots there. Alright, so first let's write down the ABC. What is A here? 1. What is B here? 0. What is C here? Minus 15. First, let's be clear about the A, B, C's. Right? Now, let's start the middle term splitting. So, I will write P of T is equals to T square minus 15 and then put P of T equal to 0. So, T square minus 15 is 0. T square is 15. So, values of T are plus root 15 minus root 15. We've got the two things. Now, let's find the sum and the product on our own, not using the relationship yet. So, what will be the sum? Plus root 15 plus minus root 15 and the sum will be 0. And if we find the product will be equals to plus root 15 multiplied by minus root 15, we will get minus 15. Now we will find using the relationship. So sum is equals to minus b by a. What is b in the question? 0. So 0 by 1 is 0. Then we will find the product. So product will be equals to minus 15 by 1, which is minus 15, and we are getting the same ones. Hence, verified. We found the sum on our own also, and then we found the sum with the help of the relationship given to us also. Reaching to the last part now, 3x square minus x minus 4. Is it in the correct order? Yes. What is a here? 3. What is b here? Minus 1. What is c here? Minus 4. Now let's find the zeros. So let px is equals to 3x square minus x minus 4, and then we put px is equals to 0. So 3x square minus x minus 4 equal to 0. So now it will be 3x square. Again 4 and 3 will be the factors. Minus 4x plus 3x minus 4 equal to 0. So if I take x only common, 3x minus 4, and here I'll take only 1 common, 3x minus 4 equal to 0. So it is x plus 1 and 3x minus 4. So what are the values that I will get here? It will be x is equals to minus 1 and x is equals to 4 by 3. So first, let's find the sum on our own. So when we find the sum on our own, sum will be equals to minus 1 plus 4 by 3. That is equals to 1 by 3. And then we find the product. Product will be minus 1 multiplied by 4 by 3. That is minus 4 by 3. And now we will find the same thing using the relationship. So that will be sum is equals to sum will be equals to minus b by a. That is using this one here. So this is minus 1 by 3. I got that. Then I'll find the product. Product is c by a. What is c? Minus 4. What is a? 3. Minus 4 by 3. It is same as we found. Hence, verified. Let's move on to the next question now. Let's continue to question number 2. Find the quadratic polynomial, each with the given numbers as the sum and the product of its zeros respectively. Now sum is given to you. That means sum here is 1 by 4 and product of the two zeros is equals to minus 1. There are two ways to do this. The general quadratic polynomial is ax square plus bx plus c. So using the given things like sum is equals to minus b by a and product is equals to c by a. If we find the values of a, b and c, we will just substitute it. We will just put it there. But how do we find those values? Now looking at the two fractions there, you have to be careful here that a and a both are in the denominator there. So that means even this product one here has to be manipulated so that the denominator here also becomes 4, right? So like I have got here that minus b by a is 1 by 4. So c by a, which is just minus 1, I'll multiply by 4, I'll divide by 4 so that I get minus 4 by 4. Now a is same in both of them. So I can conclude a is 4. What is b now? B is minus 1. If I transpose this minus sign that side. And what is c here? Minus 4. So I found all the three values. 4, minus 1 and minus 4. So let's just put the values. A was 4. So it is 4x square minus x minus 4. And that is it. That's your answer. The other way is that k times x square minus sum of the roots multiplied by x plus product of the roots, where k will be used to get rid of the fractions and we can drop that also at the end. So it is k times, we don't know what it will come here. So it is x square minus sum is given 1 by 4x, product is given minus 1. So I'll take the LCM here so that it all becomes, the coefficient becomes whole number and then drop that k also. So this will be actually 1 by 4 if I take out, it is 4x square minus 1 minus 4. And then we'll drop the k also because it is k times. So your answer is 4x square minus 1 minus 4. So you can choose any of the two options, whichever is comfortable and clicks easily to you. Then we have the second part where sum is root 2. Sum is root 2 and product is 1 by 3. That means b by a is root 2 and c by a minus b by a. C by a is 1 by 3. So now a is not same in both the cases. We will make a same in both the cases and we'll get the values of b and c also. So if this is 3 here, it should be 3 here also. So multiply by 3. So I get 3 root 2 by 3. Now A is same in both the cases, which is 3. So what will be B? I'll transpose this minus sign that side. Minus 3 root 2. And what is C? C is 1. And what is the standard equation? Ax square, standard polynomial, bx plus c. Let's put the values. 3x square minus 3 root 2x plus 1. That's it. You're done. 0 and root 5. Again, I'll write straight away now. B by A is 0, minus B by A is 0, C by A is root 5. So obviously this is also upon 1, this is also upon 1. So straight away got the values. A is 1, B is 0, C is root 5. And AX square plus BX plus C will be x square, it is 0x plus root 5, or your answer is just x square plus root 5. Minus 1 by 4 plus 1 by 4. So here I'll write straight away minus b by a is minus 1 by 4 and c by a is 1 by 4. Now in both the cases a is 4. So I don't have to make the fractions equivalent through the denominator. A is 4, so B will be 1 because this minus and minus sign will get cancelled. And C is 1. So writing it as AX square plus BX plus C, it will be 4x square plus x plus 1. Done. Moving on to the last part of the exercise. This is sum is 4. That means minus b by a is 4 by 1 and c by a is 1 by 1. So what is a? 1. What is b? Minus 4. Do not forget this minus sign. And c is 1. Putting it in ax square plus bx plus c, you will get x square minus 4x plus 1. And this completes the exercise.